Good morning students. Welcome back to the session. In the previous video we discussed theorem angle subtended at the center is twice the angle subtended at any part of the circle. Any part of the circle. Angle subtended at the center is double the angle subtended any part of the circle. So this is the theorem what you learnt in your previous video. And you also learned that angles in the same segment are equal. The angles in the same segment are equal. The next theorem, that is the angle in a semicircle is a right angle. The angle in a semicircle. See here in this figure, AB is the diameter of the circle which passes through the center of the circle. So, angle in the semicircle. So, these two portions are semicircles, right? So, ABB is a semicircle. Now, angle in the semicircle is always a right angle, that is 90 degree. Angle APB is equal to 90 degree. How you will prove this? You already learned the theorem that angle subtended at the center is double the angle subtended at the any part of the circle, that is remaining part of the circle. It means this angle is half of this angle or angle AOB. So angle AOB is equal to twice the angle of APB. Angle AOB is equal to twice the angle of APB. You know that AOB is the diameter of the circle. So what is the angle over here then? 180 degree, right? So 180 degree equals to 2 into angle of APB. So angle APB equals to 180 by 2, which is 90 degree. Therefore, angle in the semicircle is a right angle. It means equal to 90 degree. Suppose if you take angle over here. So AB is the diameter. Then what is the angle over here? Which is also 90 degree, because AB is the diameter passing through the center. So what about angle at the center? Which is 180 degree. So that this angle AQB is also 90 degree. Now see here in these three figures. See here in the first figure, AB is the diameter of the circle with center O. Right? Now, so angle ACB equals to 90 degree, because angle C is in the semicircle. So angle ACB equals to 90 degree, because angle in the semicircle is a right angle. Now see here, in this figure also PQ is the diameter because it is passing through the center. Therefore, angle in the semicircle, that is angle R, is equal to 90 degree. Similarly, in this figure, SU is the chord passing through the center of the circle, right? So that angle T is also 90 degree. The angle in a semicircle is a right angle, whether it is in this part or this part. Semicircle means both the parts are equal. Whether it is in the first part or the second part, the angle will be a right angle. So, the angle in a semicircle is a right angle. Let us see some examples. Now, in this first figure, figure 1, angle subtended at the center is 130 degree. Angle subtended at the center is 130 degree. Then what is angle ADB? Angle ADB is half of angle 130. So ADB, angle ADB is equal to half of angle 130 degree. So what is half of 130 degree? That is 65 degree. So angle ADB is equal to 65 degree because theorem. So angle subtended at the center is double the angle subtended at any part of the circle. So when angle D is 65, then angle C is also 65 degree. Angle subtended at the center is given as 130. So that angle ADB equals to 65 because angle subtended at any part of the circle is half the angle subtended at the center. So that 130 by 2, which is 65. When D is 65, C is also 65 because angle D and C are in the same segment. Angles in the same segment are equal, so that angle C equals to angle D. Then see here PQ. In this figure 2, PQ is the diameter of the circle passing through the center. So that what is angle PRQ? So angle PRQ equals to 90 degree because angles in the semicircle is a right angle. So that angle R is equal to 90 degree. Now in this figure 3, find angle U. What is angle U? Angle U is half of angle subtended at the center, that is 50 degree. So which is 50 degree. Now in this figure, now figure 4. So in this figure you see, here you can see many chords. PS is chord, SR, RQ and PQ are the 4 chords drawn in this circle and O is the center of the circle. Now if you take PS as a chord, then this portion is the minor segment and the unshaded one is the major segment. So angles in the same segment are equal, so that this angle will be equal to this. Angle PQS is equal to angle PRS because they are in the same segment. If you take SR, so SR is another chord. So the shaded one is minor segment and this portion is the major segment. So angles in the same segment are equal, so that angle SPR is equal to angle SQR. Angles in the same segment are equal. If you take RQ, so this is another chord. So this shaded one is the minor segment and this portion is the major segment. Now on this arc, so on this chord, what are the angles here? See here, RSQ. So angle RSQ is equal to angle RPQ. So these two angles are in the same segment. Now if you take PQ as a chord, then see here PQ is a chord, then this is the minor segment and this one is the major segment. Then angles. So angle PSQ is equal to angle PRQ. So see here, when you take PS as chord, then these two angles are equal. Then if you take SR as a chord, then these two angles are equal. If you take RQ as a chord, then these two angles are equal. And when you take PQ as a chord, then these two angles are equal. The theorem is angles in the same segment are equal. Now see here. Here many chords once again, AB, BC, CD and AD. But BD joint which is passing through the center. Therefore, angle in this semicircle is a right triangle, so that angle A is equal to 90 degree and C is also 90 degree. Angles in the semicircle is a right angle, so that angle A equals to 90 and angle C is also 90. Similarly, here also we can find the equal angles for GH. For chord GH, angle HEG is equal to angle HFG. If you take this HE as a chord, then angle EFH is equal to angle EGH. So these two angles are equal. Similarly, you can identify angles in the same segment, angles in the semicircle, and you can also find the relation between angles subtended at the center and the circumference. I hope you understood this. Thank you, students.